In the last astronomy unit, we talked a lot about faraway things, like stars and the Big Bang Theory, black holes, things like that. In this astronomy unit, we are going to talk about more close-up things, planets, moons, space exploration, things like that. And we're starting with the very first basic stuff, about how people first viewed the sky. When they looked up into the sky, people noticed that there seemed to be 7 objects that moved separately from the stars. Maybe take a second and think about what some of those objects were. Certainly the sun moves separately from the stars. The moon, obviously. What are some of the other things? Well, here are what the 7 that they were. So you can see the sun, moon, Mercury, Venus, Mars, Jupiter, Saturn, that move separately from all the other stars. Think of these planets and the number 7. It factors a lot into kind of our everyday lives. What do we have that's named after these 7 wandering stars? Okay, hopefully you figured out, but these are our 7 days of the week. Maybe it was a little bit easier if you know Spanish, and I don't know my Spanish very well, but I do know that we have things like lunes and miércoles, martes, viernes. Okay, so we have our 7 days of the week, which are named after these 7 different wandering stars. Imagine if they had seen 8 different things, or 5 different things. Our days of the week, or our week would be a lot different. We'd have fewer days, or maybe more days. Well, now we think that there are 9 planets, well, or maybe 8, or maybe 10. Kind of, goes with what you believe. We're kind of stuck with 8 now, with Pluto being taken out. We're probably going to talk about there being 9, just because I don't want to leave Pluto out. We can talk about it too. So here is kind of a picture of the solar system. Solar system are the planets and other stuff that share gravitational forces with the sun. The solar system is huge, but there's not much there. If the mass of everything but the sun in the solar system was added together, it'd make up less than 1% of the sun's mass. So adding up the mass of all of these planets, all of their moons, all the comets and meteorites and everything, would be less than 1% of the sun's mass. And like this picture, shows you our planets, and you'll need to know the planet order. So we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and then Pluto. Pluto is now called a dwarf planet, along with Ceres, which we used to consider as being the biggest asteroid, Makemake, and Eris. We're going to consider Pluto to be a planet when we talk about our planets, just because it always used to be, and why not? Doesn't hurt to learn about it. There have been 2 main views of the solar system throughout history. The first and kind of long-standing view was the geocentric. Geocentric solar system, think of the word geocentric. What's going to be in the center? Well, the Earth. Okay, geo is Earth. So it's an Earth-centered solar system. It's based on the apparent motion of the sun, the stars. It did not explain retrograde motion, but the Ptolemy did. Aristotle was the main person that proposed this view. So I'll write him up there for you. Aristotle. And you see one picture here of what they thought. Earth in the center, then the moon, Venus, Sun, Mars, and different stars around. And I'll show you a couple more pictures on the next slide. And I'll mention what this retrograde motion problem was. We need evidence. What is some evidence for the geocentric solar system? There's a lot of it. And a lot of it is what you have all seen your whole lives. The sun appears to go around the Earth. It rises in the east, goes across the sky, and sets in the west. The stars, if you watch them at night, they rise on one side, go across the sky, and set on the other. The moon, again, it appears to go around the Earth. One of the main things is the Bible tells us, or you can interpret the Bible to mean that the Earth is the center of the solar system. It doesn't say it explicitly, but there are some lines in it. Some of the ones that people point to are in 1 Chronicles that says, "The world shall be stable, that it not be moved." In Ecclesiastes, it says, "The sun also ariseth, and the sun goeth down, and hasteth to his place where he arose. One of the big interpretations, though, comes from Joshua, where Joshua was speaking to the Lord, and he was delivering the Amorites before the children of Israel. They were fighting with their enemies, and he told the sun to stand still and the moon to stand still. And it happened. So a lot of people interpreted that in meaning that the earth was a center and the sun was going around it. I'm sure you've heard of Martin Luther. He founded the Lutheran Church. He wrote a big letter that talked about this. And I'm not going to read the whole letter, but his end says, when he's talking about Copernicus, who we're going to talk about in a little bit, he says, "The fool wants to turn the whole art of astronomy upside down. However, as Holy Scripture tells us, so did Joshua bid the sun to stand still and not the earth." So he's saying that the sun isn't the center because Joshua told it to stand still. If it was in the center, he wouldn't have had to have told it to stand still. He would have told the earth to stand still instead. So people believed that the Bible said that the earth was the center of the universe. And I like this one. The birds and clouds are not left behind. Kind of a fun one. They think the birds and clouds are up there in the sky, and if the earth was moving, then whoop, they'd be left off in space. So the earth can't be moving. Kind of a fun one. Here are some more views of this geocentric solar system. I like this one. The earth is in the center, the moon going around it. You have Mercury, Venus, Sun, angels and demonic beings, Jupiter, Saturn. In this picture you see these little curlicue things, these ellipticals. That was the problem with the Aristotle view. If you would be observant, you'd go outside at night, you would see the planets, like Mars for example. You'd see it moving across the sky like you normally think it should, but then it'll back up, and then it'll go forward again, like that. Well, that doesn't really make sense if Mars is just going around the Earth. And that troubled a lot of people. But then Ptolemy came along and said, oh, I have an explanation. Mars doesn't go around the Earth in a nice circle like this. Mars goes around the Earth with little ellipticals, and so do the other planets. So it's cruising around like this. And this little elliptical would explain how Mars would appear to move backwards in the sky over a series of nights. So Ptolemy explained that, and everybody was like, okay, good, now everything works again. But there was a guy named Copernicus, a Polish astronomer, who said, well, that's not right. We live in a heliocentric instead. So what's the center? Helios? The sun. We live in a sun-centered solar system. It was based on real motion. Copernicus proposed it in 1543. He dedicated his book to the Pope, trying not to get in trouble because he knew this would be inflammatory. He said, the Earth is not the center of the universe. It is only a satellite of the sun. How do you think it went over? Not very well at all. The book wasn't published in most places. Copernicus recanted what he believed, and he didn't really say much more about it. Galileo came along later. He was brilliant. We'll talk a lot more about Galileo if you want to hear about him, all the amazing things that he did with medicine, with math, and of course astronomy. Galileo read about this later in his life after he had improved upon his spyglass, what we know of it as a telescope. And he was a little bit more bold than Copernicus. Once he believed it, he was going to tell everybody about it. And that's what got him into trouble. He was called in front of the Inquisition. He was forced to kneel down, recant his beliefs. He eventually kept preaching about it, and he was thrown into jail for the rest of his life. Now, it wasn't kind of like a real jail. It was basically house arrest, because he was the great Galileo. He was infamous at that time. But he was still got in trouble for believing and preaching that it was a heliocentric, not the geocentric. And there's Galileo. And there's a picture of his index fingers. They have them in the Galileo Museum in Florence, and my wife thought it'd be funny to photobomb my picture of Galileo's fingers that they have in Florence. So what is his evidence? Evidence is a lot harder to find, which is why people didn't believe him. It was easier to believe geocentric. There is some evidence, though. First thing is Jupiter's moons. He saw that Jupiter has moons. If they're going around Jupiter, that means they're not going around the Earth. The Earth is not the center of the universe. The retrograde motion of the planets, that backwards motion that Ptolemy tried to explain, Galileo thought that was ridiculous. And here you see the retrograde motion of the Copernican system. What it is, because the Earth is closer to the Sun, the Earth goes faster, and that's why it makes Mars appears to go backwards, and you see the sight view. So it appears that Mars goes backwards because the Earth is just going faster than it. Polaris, the North Star, it doesn't move. Therefore, the Earth is not the center of the universe. Mercury and Venus are never far from the Sun. If you watch in the sky for Mercury and Venus, they'll always be a little bit before sunrise and sunset because they are closer into the Earth, or closer into the Sun than the Earth is. Also, Venus goes through phases. Just like the Moon goes through phases, you might have a crescent Venus, a full Venus, a quarter Venus, and the only way that can happen is if it orbits around an object that gives off light. That would be the Sun. So, we have our new heliocentric version with the Sun in the middle. The first 4 planets are called the terrestrial planets. They are Earth-like. They're solid. Okay? The next 4 are the Jovian planets. They are the gas giants. They're made of gas. Pluto, Eris, Makemake, and Ceres are separate and unusual. They are solid, but they don't really fit into either of these classifications. Let's look at this picture really quickly. Just our final picture for this section, and it just shows you the orbits, how mostly they're fairly circular, but you see Pluto's orbit is very eccentric. One of the reasons why Pluto isn't considered a planet anymore. It is not cleared its celestial neighborhood, and that's why they reduced it to a dwarf planet status. You see the picture here, and it looks like Neptune and Pluto could hit each other. They can't. This is just a 2D picture. In 3 dimensions, they never get anywhere close to hitting each other. And I can do a demonstration of that in class to show you. And that is the first section about our solar system views.